Gas chromatography is a widely used separation technique where a sample is segregated into its individual compounds. In this technique, a sample is dissolved in a mobile phase which is passed through a stationary phase where actual separation happens. What is the mobile phase? It is a carrier gas that carries the sample through the column to the detection system, that is, to the detector. The mobile phase is ideally an inert gas like helium, argon, or a non-reactive gas like nitrogen. In some cases, hydrogen is also used as a carrier gas. What is a stationary phase? The stationary phase is the material packed inside the column. It could be liquid or solid. If the phase is liquid, it is generally non-volatile in nature with a high boiling point. This liquid phase is either coated on an inert solid sorbent like silica particles that is packed inside the column, for packed column, or is directly coated on the walls of column, for capillary column. What is a column? It is a coiled tube that holds a stationary phase inside. Columns are made of materials that can withstand high temperatures and that are resistant to corrosion. Working principle. The basic principle behind gas chromatography is partitioning of components of the sample with respect to their affinities towards the stationary phase. The affinity of compounds towards the stationary phase is determined by the intermolecular interactions as well as the polarity of the stationary phase. Each compound eluted from the column reaches the detector in a sequential way. That is, the early eluting compound reaches the detector first, and the late eluting compound reaches later. Each compound reaching the detector generates an electronic signal in the detector. Different compounds generate signals of different amplitudes which are directly proportional to their concentration in the sample. More the concentration of the compound in the sample, higher is the signal. A detector amplifies and measures the signal. Example, a flame ionization detector, FID, is the most common and popular detector used. It responds to most of the organic compounds. A peak is the identity of that compound. Compounds with different retention time generate separate peaks. The area and height of the peak is directly proportional to the concentration of the compound. Previously, strip chart recorders were used to gauge the output of chromatograms, which were then manually processed to calculate the peak areas or heights and the final concentration of the analyte. Nowadays, GC systems are equipped with computer-based integrators and data processing softwares that record the signals from the detector, process them and print them in the form of chromatograms. For carrying out quantitative analysis in a GCMS, the system needs to be calibrated by injecting known amount of analyte compounds. Switch on the carrier gas so that the required carrier flow is established. The instrument is then powered on. Let the carrier gas purge through the system for 10 minutes.